Okay, this is a review for the Unit 3 test, and just so it doesn't make it so long, I'll probably just go through these quite briefly, and we can, if you have any questions about them, please feel free to email me. But question number one, you want to be prepared for a constructing a perpendicular bisector, and this if you want to write the steps down, that would be good. Construct it. That will really help you learn the steps in constructing a perpendicular bisector. Question number two is going to be a proof involving a perpendicular bisector, and it's going to be a click and drag proof. If you want to stop and pause, or actually pause these and look at what you think this is going to go, that'd be great. But I'll just go ahead and finish this one. It says DC is a perpendicular bisector of AB. First of all, you want to read your givens and your proof. Given DC is a perpendicular bisector of AB, prove that AD is congruent to BD. So what we want to do is the first line you definitely want to put the given in. So DC is a perpendicular bisector of AB, and of course the reason is given. So they're going to derive this next statement from here. Okay, you can't write just any random statement. It has to be derived from something previously proven. And since we've proven that DC is a perpendicular bisector, they give us that AC is congruent to BC. And that's because this is a bisector, and that's true. So what we have here is, we know that AC is congruent to BC. Okay, and that's the very definition of a bisector, of a perpendicular bisector. And then the next one, of course, again, you can't just come up with reasons out of thin air. They have to be derived from previous statements. It says angle ACD and angle BCD are right angles. And again, that comes from perpendicular bisectors. We know that these are right angles because of the perpendicular bisector. Okay, so let's go ahead and put that right there. And then the next guy they did for us, angle ACD is congruent to angle BCD because all right angles are congruent. And they're just saying that this angle is congruent to this angle. And then why did they do that? Well, because it's not enough for them to be 90 degrees. We have to state that they are congruent as well, because this side is congruent to this side, this angle is congruent to this angle, and the next thing we want to prove is this side congruent to itself, because what we're trying to establish here is that these two triangles are congruent to one another by side angle side postulate. Okay, side angle side. So we know that, look at this, the last statement, prove AD is congruent to BD. How do we know that? Because we've proven these two triangles congruent. And since these two triangles are congruent, all the rest of the parts are congruent. And that is called CP/CTC, or congruent parts of congruent triangles are congruent. This guy. Okay? Question number 3 is going to be another proof, and it's going to involve angle bisectors. Now, it's not going to look like this, but it gives you the idea. And again, it's going to be using CP/CTC. So, we are given that YX is congruent to WX, and we're also given that ZX bisects YXW. So ZX bisects YXW, which happens to be XYW, which happens to be an angle bisector. So those are the two pieces of information they give us. So what I'm going to do is I'm going to start out my proof with those two given statements. Let's go find them. Let's see, YX is congruent to WX. That's given. And ZX is congruent to angle YXW. That is given as well. Okay, so those are my two given statements. I can't use them again. You can see that I got them from here, given. So I can't use the reason given again. The only time you can use given is from this. Okay, we want to prove that YZ is congruent to WZ. So let me tell you something. Let me give you a hint. Our last statement is going to be just that. It is going to be what we are trying to prove. So just so you know, this is going to be here. So what are we going to come up with next? Well, what I want to do here is, if I can look at this, I want to think, well, if I can prove that this triangle is congruent to this triangle, all right, and I know that kind of throws you off maybe a little bit because it's hard to see. I mean, there's triangles within triangles, right? So maybe let's highlight it a little better, that this triangle, XYZ, is congruent to this triangle. Let's do XWZ right there. Okay. So if I could get those two triangles, if we can prove them to get congruent, then I could totally say, well, then these parts are congruent by CPCTC. Okay. So, and I can totally do just that because look, we have side, angle, and guess what? XZ is going to be congruent to XZ. And we can use that because of reflexive property right there. So guess what? Oh, I guess we're going to fill in the blank here. So triangle XYZ is going to be congruent to triangle XWZ by side angle side. And then, ooh, I got one too many rows. YZ is congruent to WZ. And that's, my friends, all there is to it. So that's question number 3. Question number 4, we're solving for X. And what we have here, of course, are vertical angles. And our vertical angles, and let's go ahead and give this little middle guy a name here, okay? We're going to name that middle guy V. If we have vertical angles, and if you guys are still having problems with this, it's just two intersecting lines, and their angles formed between those two intersecting lines are called vertical angles. And the non-adjacent angles, which means the ones that aren't side by side, are called vertical angles. These happen to be congruent. So if we want to solve for X, we of course just set them equal to each other. 12x minus 6 equals 5x plus 50. And then we go ahead, and this should be elementary to you guys at this point, solving for x. We're going to bring the 5x over and subtract it. If we were doing proofs, we could totally say this is subtraction property of equality. Add the 6, that's going to be 56. So that 7x equals 56. So x equals 8. Now, what if they wanted us to solve for the measure of angle, let's say SVT? All we need to do is plug the 8, what we just solved for, in for x. Okay? And so, what we have here is 5 times 8 plus 50, and so we get 90. Okay. Question number 5. They're dealing with corresponding parts of congruent triangles. So triangle QRS is congruent to triangle WXY. What is the measure of angle W? Well, we can see that Q corresponds with W. Okay, so we know that those two are congruent, so we know that measure of angle W equals 63 degrees. So that should really help you determine what to study for the Unit 3 test. Question number 6 has to deal with rigid motions, and you're really going to need to have your rules of reflection and rotation. How can we prove that ABC, triangle ABC, is congruent to triangle DEF? One is supposed to be an F there. Oh, geez. DEF. So that is the big thing there. How are you going to prove those with rigid motions? I'm going to go ahead and solve one of those right now for you, and then you can figure out how to do the other one. But I can see, now remember, if you use orientation, that will help you. So it'll help you determine if it's a reflection or a rotation. So ABC, the problem is you really can't tell which parts correspond with which, you know? So maybe that isn't the best idea, because sometimes if it said A prime, B prime, C prime, then yeah, then you would check orientation. But man, is this a reflection or rotation? Well, let's see. Let's just start off with maybe a rotation of 90 degrees counterclockwise. Let's just try that. So what I'm going to do here is I'm going to take my A, take my B, take my C, and I'm going to write the coordinates down. And I get 2, 3. B is, and I should say -2. No, those are wrong. My heavens. My heavens. -3 and 2, right? Geez, low. -3 and 2. B is -9 and 3. And C is -4 and 7. Okay. So when I do a 90-degree rotation counterclockwise, that's going to have the rule of -y and x. So when I do that, when I apply that rule, what I get here is -2, -3, -3, -9, and then we get -7, -4. Okay, so let's go ahead and graph these points down here. I'm going to use a different color actually, so that we can see these. Hold on. Okay, there we go. Okay, so we're going to go ahead and graph these points here. -2, -3. So -2, -3. Maybe if I choose the right color, right? -2, -3. Oh, interesting. How about -3, -9? Fantastic. So, and then of course -7 and -4. So we can see that we can prove these two triangles congruent by rigid motions. Okay, so we know that triangle ABC is congruent to triangle D, and this should be E, D, F, DEF by a 90-degree rotation counterclockwise. And they might add in a translation too, so be prepared for that. So 90 degrees rotation, and then they might say translate, whatever. So be prepared for that. All right, so question number 7, same exact thing. You're going to prove triangles congruent with rigid motions. Make sure you have the laws of the rules of reflection and rotation that we've talked about so many times in our class connects. Handy, printed, use them. Feel free to use them on the test. I don't care if they're sitting there right in front of your face. Feel free to use them. Okay. Question number 8 is going to be dealing with what is the corresponding congruent part for each segment or triangle. And all they're going to do is they're going to give you this name. Triangle FEG is congruent to triangle MNO. Well, just by looking at the name, I know that FE is congruent to MN. Okay. And right there. Okay. And for instance, angle F is going to correspond with angle M. All you got to do is look at the name and you know how they correspond. Question number 9 is just simply writing a congruent statement. Which parts correspond with which parts? So for instance, R corresponds with F. We can tell by the simple one-arced tick mark. We can tell that T corresponds with D. Why? Because the one arc and the tick mark. And then S corresponds with S corresponds with E. So we could totally use that to help us write our congruent statements. We could say, well, triangle RST is congruent to triangle FDE. FDE. So don't go by alphabet alone, okay? You have to go by corresponding parts, okay? You need to know how to construct a square. So make sure you know how to do that. Of course, you'll start with your line segment with 2 endpoints, okay? Like so. And then just like normal, you would construct a perpendicular bisector. But this time, let's be specific and make the radius of the circle or the compass, the radius of the compass. I'm using a circle because you can't use a compass in Class Connect Blackboard. I wish you could. There you go. So what we're going to do is construct a circle, use a circle. Let's see, let's go ahead and copy that, and we're going to paste that so I don't have to do it twice. There we go. So what we just did was we're going to construct a perpendicular bisector, and so you can use this for problem number 1 as well. So when I connect those two intersecting circles, and everything's not going to be accurate on this because it's just using, estimated circles that from looking at it, but so what we just did was create a perpendicular bisector. Now what we're going to do is we're going to create a circle using that intersection of the perpendicular bisector as the center of a circle here. Let's try not make it an oval. There we go, that looks good. Now what we just did was we found 2 more points. We found this one here, and we found this one down here. So we have 4 points, like so. Here, 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 here. Okay? And we can just connect those dots. And I'm going to change it to color so you can see it maybe a bit better, maybe a bit thicker. And there is our square. Now, like I said, this is maybe not 100% accurate because like I said, I've been eyeballing things, but there is our square. Pretty cool. And then problem number 11, you need to prove which quadrilaterals are congruent. Again, you could totally use rigid motions to help us prove quadrilaterals congruent. You can also prove distances, but I would use rigid motions to help us prove that these are congruent. Or yeah, like I said, you could also maybe use distance 1, 2, 3, 4. So 1, 2, 3, 4. So 1, 2, 3, 4, 1, 2, 3, 4 to kind of help get you started. But then we can also see, oh, well, this goes over 1, up 3. This one goes over 1, up 3. You can do the same thing here. This one goes down over 3. This one goes down over 3. So you can tell that 1 and 2 are congruent by using slopes and distances. Okay. And then the last question is going to be just looking at rules. Can we tell if the transformation is congruent or not congruent? Well, if it's a rigid motion, you know they're going to be congruent. If it's not a rigid motion such as a dilation, then they're not going to be congruent. So I could tell if this is a translation, so that would be congruent. This is a reflection, that would be congruent. This is a dilation because it is multiplying each point, doubling it, and this is going to be a dilation as well because it's multiplying the point as well. This is going to be an expansion. This is going to be a contraction. I know that was a very brief Unit 3 test overview, but hopefully it'll help. Coupled, we do go over these questions in Class Connect, so if you weren't attending live, you need to watch the recordings to help you go over these questions. So, all right, good luck. Oh, I think there might be one more actually. There's not. And best of luck to you.